Okay, so let's take a look at this question. A gas tank is leaking gas. We know that after 11 hours, 2,978 gallons of gas remain in the tank. And after 17 hours, 1,332 gallons of gas remain in the tank. The tank company wants to graph a line to represent this situation visually. What equation should they use? And we should also add that leaking, it is leaking at a constant rate. Constant rate. I should have written in that we know that to be a fact because the only way that we could accurately graph this situation with a straight line is if it were leaking at a constant rate, correct? Because only if it is leaking at a constant rate is this relationship a linear relationship. Therefore, only then could it be considered a linear function, and only then could it be accurately graphed visually with a straight line, right? Okay. So let's get started and see how we can figure this out. Well, we know that the equation for a line is y equals mx plus b, right? Where we know that m is the slope of the line and that b is the y-intercept, right? And we know that if we're using this line to graph a linear function, that m is the rate of change, right? M is the rate of change of this function, and b is the initial value of this function, right? Okay, so we're not outright told what the rate of change is, nor are we outright told how much gas this tank had in it before the leak started, which would be the value of our initial value, right? So we have to figure that out by finding two data points, right? Two data points, because once we find two data points, we can calculate change in y over change in x, or rise over run. Then we can find the value of m. Then we can use that information to find the value of b and get our line, right? But first, we have to find our two data points. Okay, what's our first data point? We know that after 11 hours, 2,978 gallons of gas remain in the tank. So we know that one data point is 11, comma, 2,978, right? And we also know that after 17 hours, 1,332 gallons of gas remain in the tank. So we know another data point is 17, comma, 1,332. That's one point where the input is 17 and the output is 1,332, right? Okay, so let me make some room over here. Let me make some room over here. Let me make some room over here. We're going to have to prepare. Whoops, we're going to have to prepare to evaluate y2 minus y1 over x2 minus x1, right? We're going to have to prepare to do that to find the value of m. Okay, so which of these 2 points should be x1, y1, and which should be x2, y2? Remember, our x1, y1 is always going to be the point with the lower x value, right? Darn, I just can't write anything correctly today, can I? Let me get rid of this. This should be x1, of course, x1 comma y1, right? And this should be x2 comma y2, right? Okay, so now let me make some more room over here, and let's get down to calculating this, okay? So what's going to be y2 minus y1? That's going to be the 1,000, whoops, that's going to be the 1,332 minus 2,978. What's going to be the x2 minus x1? That's going to be the 17 minus 11, right? Okay, so what's our numerator going to be? We're going to calculate that numerator there, and we are going to get negative 1,646. It makes sense that it should be a negative value since this gas tank is losing gallons of gas, so our rate of change should be negative. And 17 minus 11 is just going to be 6, right? Just going to be 6. Since this is a scientific, sort of a scientific scenario, right? Kind of. Let's actually find this m value as a decimal. So that's going to be negative 274.33, okay? All right, so let me create some room over here. We've just found one important piece of information, haven't we? We've found one important piece of information. Get my brush back. We found that m equals negative 274.33, right? So how are we going to find b? How are we going to find b? Well, we've done this before, haven't we? Now that we know our m, right, we're going to take one of our data points. Let's take 11, 2,978, right? So at this data point, x equals 11, right? And y equals 2,978, right? And now that we know m, we can substitute this value of x, this value of y, and this value of m into our equation for the line, right? So we can substitute 2,978 equals negative 274.33 times 11 plus b, right? Because b is our last unknown. Well, that's going to equal 2,978 equals negative 274.33 times 11 is negative 3,174.63, and then that's still plus b. What do we do to solve for b? Clearly, we're going to add 3,017.63 to both sides, right? Because that's what we need to do to get b by itself on the right-hand side. And b is going to equal what? It's going to equal, let me calculate this. It's going to equal 5,995.63. So that's the amount of gallons of gas that this tank started with, okay? All right, so we've got M, right? And we've got B. Step by step, we have found all this information, so we can finally tell this gas company that the line they should use to graph this situation is y equals negative 274.33 x plus 5,995.63, right? There we go.